Today's lesson is on 4-2 on increasing and decreasing functions. We're doing the first derivative test for relative extrema. So we just need to go over the procedure here and you'll find out it's not too bad. The first step is find the domain restrictions, which means just find what x can't be. Number 2, find all critical numbers. Now a critical number is a new concept, and what a critical number is where the derivative is equal to 0 or where the derivative is undefined. And like we said, our critical numbers cannot be our domain restrictions. So you got to watch out for that. Once we locate critical numbers and the domain restrictions, we're going to do what we call a number line test. And we'll go through and label it. Then on number 5, increasing means where we're positive, decreasing means where it's negative, and then we'll talk about which one's a max and which one's a min. So we're going to start here with our first problems by locating the critical numbers. And like we said, to locate critical numbers, we need to take the derivative and set it equal to 0. So I already know you guys know how to find the derivative of these functions. So because of time, I'm just going to write the derivative down in its cleaner version. So there's my derivative, and we set it equal to 0. So I set that top equal to 0 because that's when the derivative will be 0. So 4x equals 0. So I get x equals 0 is a critical number. But remember, also with critical numbers, it talked about when f of x is undefined. Well, where is this derivative undefined? When that bottom is set equal to 0. So I set the denominator equal to 0. And I get x equals plus or minus 3. So we're going to do a number line. And you plug in your numbers on the number line. And now we're going to do a number line test, which means I don't know what's going on with the mic, sorry. Means we're going to test within the derivative because we want to know when is the slope increasing and decreasing, so it doesn't make any sense to go to the original function because the original function gives me y values. It doesn't tell me anything about the slope. So if we plug in a -4, I know I'm going to get a negative up top. -4 in here gives me a positive. 16 minus 9 is still going to be a positive, so a negative over a positive is a negative. Now if I plug in -1, that's going to be negative. -1 in here, that's going to be -1. I take the cubed root of a negative number. That's okay. It's going to be negative. So a negative over negative is a positive. Now plug in +1. Positive, negative, so therefore negative. Plug in 4. Positive over positive, so therefore positive. So keep in mind, this is for f prime. So I know it's decreasing from -3, from negative infinity to -3, then it increases from -3 to 0, decreases from 0 to 3, and 3 to infinity. So, sorry, I should have been labeling that. So increasing, wherever it's positive, -3 to 0, and from 3 to infinity. Therefore, I'm decreasing from negative infinity to -3 and from 0 to 3. So then it wants you to locate extrema. Well, extrema just means max or min. That's the plural form of it. Well, keep in mind, if I'm going decreasing to increasing, that means I have a min right there, a max right there, a min right there. So I know there is a min two mins at -3 and one at +3. And then there's a max at 0. So how do we get those y values? Well, then from there, we would plug into the original because we want y. And if we plug in 3 or -3, we're going to get 0 there. And if we plug 0 into the original, you'd have to use your calculator. -9 raised to the 2/3, and I did look that up. That's 4 point, where did it go? 4.326. So there's our max. So because of the first derivative, we can find our max and mins. And before in pre-calculus, the only way you could do that is with a graphing calculator. So there's number 1. Okay, now we're going to look at number 2. To take that derivative, once again, we'd have to do the quotient rule. But because of time, I'm quickly going to write what the derivative is, cleaned up after everything. So there is my derivative. Okay, one thing we need to check, do I have any domain restrictions? Is this function continuous? And I know it's a fraction, so I know I need to be careful. So we notice x can't be equal to 0. So that's a domain restriction. We got to watch out for that. So now that I have my derivative, we set it equal to 0. So if you notice, you could factor out a 9. I'm going to show you the factored form here. And you get x to the 4th minus 1, which could factor even more to 9. And that would be like x squared minus 1 times x squared plus 1. So then I can factor that more to x plus 1, x minus 1, and x squared plus 1. If you wanted to go all the way down to factored form, just kind of let you see what's going on. And yeah, those 9s can cancel out. Okay, so now we need to find our critical numbers. I already know, I'm going to put a line there so I know 0 is an asymptote. I'm putting it on the number line because if well, I'll explain it in a minute once we find all our critical numbers. Okay, so we set it equal to 0, and we get -1, +1. It's also undefined at 0, but we already know x can never be 0 because of the original problem. It's a vertical asymptote. So now here we go to do the number line test. If I plug in -2, that's going to become positive. That's going to be positive. Positive over positive, positive. Okay, now plug in, and then I know over here, that's going to be positive as well. Now plug in -1/2. And you plug in -1/2, you get 9/16. You're going to have to get common denominator. The negative is going to be bigger. So a negative over positive, negative. I know it's going to work with the even numbers as well. So now I'll talk about where is the function increasing. Well, it's increasing from -infinity to -1 and from 1 to infinity. Therefore, it's decreasing. Now, this is what I mean, why you have to have that domain restriction. You cannot say it's decreasing from -1 to 1 because I have now included that asymptote, which we cannot. So that's why it's important you understand your domain restrictions. You have to say from -1 to 0 and from 0 to 1. So don't forget that. Well, now we need to know, do I have a max or a min? Well, if I go from positive to negative, I know that's going to be a max. Nothing's going on there, and plus it can be a max or min because we have vertical asymptote. Now I'm going from negative to positive, so I have a min. So we have let's come here, a max at -1, a min at +1. And to get those y values, you would plug back into the original. So our min is, what was it? 4/3. And then our max was -4/3. So there we have where it's increasing, decreasing, and our max and min. So this starts to give us an idea of what this graph looks like. So if you can tell, soon we're going to throw all this together with our curve sketching. And you can draw everything accurately of the graphs without a calculator. Okay, so number 3, the derivative of this one is 3x squared minus 6x plus 3. We factor out a 3 out of everything, and we get x minus 1 squared. Do I have any domain restrictions there? Well, I don't. It's a polynomial, which means it's continuous. So everything's good. Now I just find my critical numbers, take my derivative, set it equal to 0. I have a critical number at 1, because I set that wherever there's an x, set it equal to 0. Probably going a little too fast, sorry. Okay, now we need to do the number line test. You always test within the derivative because we want to know the slope. So if I plug in 0, I get a negative times a positive. Well, look right here. So that is squared, which means, what are we going to get right there? That means that this is always going to be positive. So we're positive the whole time, which means we're increasing from negative infinity to infinity, never decreasing. So do we have a max or min? That means there is no max or min on this. So it's a cubic function, meaning it looks something like that. Except I should have been over here at 1 and done that. Doing that right there. Okay. So the last thing, just read over these things right here. So the function in example number 3 is what we call strictly monotonic, which means it's strictly increasing or decreasing. And one other thing we've talked about, hopefully we've noticed, that not every critical number produces a max or min. So even though we got critical numbers, if the sign doesn't change from a positive to a negative, like it did right there, with that strictly increasing, it doesn't mean you're going to have a max or min. Let's see what this last thought was. Even though the slope at x equals 1 is 0, the function is always increasing. So it's just talking still on that example number 3. The slope there at 1, it is 0, but we didn't change from increasing to decreasing. So we didn't make a max has to occur on a hill, a min is down in the valley. You have to change from increasing to decreasing, and a max from decreasing to increasing. So that's all of word 2. If you didn't get that, then watch it one more time. Oh, we didn't do our